Voyager 2 showed nitrogen plains, sharp ridges, and a pinkish ice cap, but the most incredible sight was the geysers, dark plumes shooting several kilometers into the sky, likely caused by icy volcanic activity. These geysers hint that there could be heat generated deep inside Triton, possibly due to Neptune's gravitational pull. Triton's surface with its cracks and smooth areas shows us that it's still changing, still active in its own frozen way. Even as it moved past Neptune and Triton, it raised new questions. What powers Neptune's massive storms? How do its fragile ring arcs stay in place? What's happening beneath Triton's icy surface? These mysteries continue to inspire scientists to explore the far edges of our solar system. As Voyager 2 said goodbye to Neptune, its twin Voyager 1 was on a different mission. After visiting Jupiter and Saturn and taking a closer look at Saturn's moon Titan, Voyager 1 started its journey beyond the planets. It took 32 years to reach the farthest point influenced by the Sun. In 1990, while drifting beyond Neptune, it captured one of the most famous images in history. Earth, seen from 6 billion kilometers away, appeared as a tiny pale blue dot. This image, described by Carl Sagan, reminded us how small and fragile our planet is in the vastness of space. These aging probes, launched in 1977, were originally meant to explore the outer planets, yet they far exceeded those goals, pushing into interstellar space. They now drift toward distant stars, continuing their mission long after we lose contact with them. Voyager 1 is moving at 17 kilometers and will eventually pass near a star in the constellation Camelopardalis in about 40,000 years. Voyager 2, on a different path, will pass by a star called Ross 248 and later near Sirius, the brightest star in our sky. Both Voyagers carry golden records filled with sounds and images of life on Earth, from greetings in different languages to music and natural sounds. These records aren't just messages for potential alien civilizations, but also a snapshot of who we are at this moment in time. As the Voyagers drift farther and farther away, they carry with them the story of humanity's quest for knowledge, reminding us of our incredible journey and the endless possibilities that lie ahead. The Voyager spacecraft have sent back information that changed what we know about the faraway planets and revealed how complex the space around our solar system, called the heliosphere, really is. Their discoveries have paved the way for future missions, showing us the need for even more advanced spacecraft to explore the edges of our solar system and beyond. These missions remind us how huge the universe is and spark our curiosity to learn about what's out there. Voyager 1 and Voyager 2 are examples of our desire to explore. They encourage us to look beyond what we already know and to search for what we don't yet understand. As the Voyagers move further into space beyond our solar system, they stand as proof of humanity's amazing accomplishments and our ongoing quest to figure out our place in the universe. Their legacy will continue to inspire future generations of scientists, engineers, and explorers. The Voyager's journey has created the foundation for space exploration in the future, urging us to dream bigger and aim farther than ever before. Even now, traveling through the endless stretches of space, these spacecraft are a lasting symbol of humanity's thirst for knowledge and adventure. This was important because it takes hours for signals to travel between Earth and the Voyagers, so the spacecraft had to be able to solve problems and do their tasks on their own without waiting for instructions. Before these missions, our view of planets like Jupiter, Saturn, Uranus, and Neptune was limited to what telescopes could show us. The Voyager probes gave us the first close-up look at these giant planets, revealing the details of their swirling atmospheres, massive storms, and moons like never before. For example, Jupiter's Great Red Spot, a giant storm, was shown in incredible detail. The spacecraft captured the movement of its clouds and gave scientists new insights into Jupiter's magnetic field and how it interacts with its moons. Saturn, famous for its rings, was also revealed in stunning detail. The Voyagers provided sharp images that showed the structure of its rings, their gaps, and how they interact with Saturn's moons. But the surprises didn't stop there. Uranus' strange tilt and Neptune's intense storms, including its great dark spot, were seen up close for the first time, giving scientists a clearer understanding of their atmospheres and geology. Neptune's strong winds and constantly changing atmosphere were especially fascinating because we had never seen anything like them before. The exploration of Neptune set the stage for our next great adventure, delving into the turbulent atmospheres of Uranus, where more cosmic puzzles await. Insights from the Voyager missions also uncovered important details about the moons orbiting these planets. For example, Jupiter's moon Europa has a thick layer of ice that might hide an ocean underneath, raising questions about whether life could exist there. Saturn's moon Titan was found to have a thick atmosphere and lakes made of methane, and Neptune's moon Triton was discovered to have geysers, which means its surface might still be geologically active. The Voyagers also found new moons and faint ring systems like the thin rings around Jupiter and Neptune. These discoveries gave us a deeper understanding of how planets and their rings are formed. They also provided important information about the magnetic fields of these planets, like Uranus' tilted magnetic field, which surprised scientists and showed how complicated the inner workings of these planets can be. In the end, the Voyager mission is not just about the scientific discoveries, it represents humanity's constant journey to learn more about the universe. Every bit of information sent back has expanded our knowledge and raised new questions. Even though it is now far from home, Voyager carries with it our endless curiosity and drive to explore the unknown. Neptune's magnetic field gave scientists a whole new way to think about what's happening inside the planet and the activity going on deep within. When the spacecraft passed the outer edges of the solar system, it entered a place where the sun's influence fades and space itself begins to change. But it didn't just disappear into the unknown, it sent back important data from the farthest parts of our cosmic neighborhood. It measured things like invisible particles, magnetic forces, and the thin gas between stars. This helped expand what we know about where the solar wind from the sun stops and interstellar space begins. These discoveries opened up a previously hidden part of the universe, moving us forward in understanding the solar system's outer edge. Even though the spacecraft is now far beyond our solar system, it still teaches us new things. The knowledge gathered lays the groundwork for future missions, helping scientists figure out how planets form, behave, and interact with one another. But this isn't the most impressive part. The data sent back continues to be like a guide for the next generation of space explorers. What was achieved doesn't just affect science, it's also changed space exploration as a whole. Today's space missions are heavily influenced by the lessons learned, whether it's keeping a spacecraft running over long distances, communicating across billions of miles, or maintaining equipment in the emptiness of space. It set the standard. For instance, the New Horizons mission, which reached Pluto, relied on technology and methods improved by the success. Staying in touch with spacecraft millions or even billions of miles away is challenging, but it showed us how to do it. It proved that even from far out in the solar system, we can send back clear data using massive antennas and special ways of boosting weak signals from deep space. But the real challenge was still ahead. These techniques became even more critical for later missions like the Mars rovers or future probes heading beyond our solar system. When it comes to exploring planets, it made some of the most groundbreaking discoveries about the outer planets Jupiter, Saturn, Uranus, and Neptune. The close-up view sparked new questions for future missions to explore. For example, the studies of Saturn's rings and Jupiter's atmosphere inspired later missions like Cassini and Juno to dig even deeper into these planets' mysteries. The foundation laid has been a map for uncovering more about our neighboring planets. This single photo became a symbol of our place in the universe, sparking a sense of wonder about what's out there. When it comes to planning space missions, it raised the bar. Its success showed how careful planning and creative problem-solving are essential. Every spacecraft launched since then has benefited from what we learned during the journey, making future missions better prepared for the challenges ahead. Missions like the James Webb Space Telescope, aiming to look even deeper into space to see how galaxies and planets formed, are following in its footsteps. But this wasn't the biggest surprise. It also sparked a new era of space exploration. Another mission inspired by it is the Europa Clipper, set to explore Jupiter's moon Europa. Scientists believe that under its icy surface, there may be an ocean with the potential for life. Earlier findings about the moons of the outer planets made scientists curious about places like Europa, pushing them to search for signs of life beyond Earth. Future missions aiming to leave our solar system are building on what was started. These next-generation probes will continue exploring interstellar space, gathering data about the unknown parts of the universe. The ideas and technology driving these missions are rooted in its work, showing just how far its impact has reached. But even beyond its scientific contributions, it symbolizes human curiosity and our desire to explore. The golden records carried aboard, filled with sounds and images from Earth, were sent in the hope that one day they might be found by intelligent beings. Even as it drifts farther into the cosmos, these records are a reminder of our dreams of making contact with other worlds. Intelligent life from other planets sparks our deep curiosity and desire to connect. We want to share who we are, our cultures, dreams, and hopes for the future. As they travel farther away from our solar system, they carry messages from us like cosmic postcards to other civilizations, hoping that one day someone out there might find them and learn about us.